Hello, hello. How's it going, everybody? A little bit late here, going with the stream. I realized well, was double checking all my audio stuff, and I got distracted by other things. So starting a little bit late here. Um, what are we doing today? Wow, scatterbrained. We are looking at a thing called Wasm-pack. So there are a few ways that we can take code that isn't JavaScript or otherwise meant for the web and put it in a form that could be used on the web. Um, One of those ways, or well, not even necessarily web, but just like within the JavaScript ecosystem. Hey, Chris, how's it going? So the with if we want to run something in like Node or Dino or any of the other flavors of JavaScript runtimes or browser, um, we either have to like run it on the side and interact across some sort of boundary, HTTP, or if you're running locally via running a binary sidecar kind of thing, you could do like ICP, GRCP, blah 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 blah. Um, but if we want to pull in code directly in and use it more directly, I think there's kind of pretty much two ways to do that. Um, and that's either through FFI or yeah, I guess it's basically FFI or Wasm if the thing that you're working with supports it. And support on the web, so within the browser, has been coming along, and you can use Wasm now in the browser. But you can also use it in, I think, Node, and you don't necessarily need experimental flag support anymore. So that's something that I want to poke around with today, partly because there's a use case in a project that I'm working on where we want to potentially pull in and use some Rust. But we're also expecting that to run in GitHub Actions. And GitHub Actions uses Node 16, I believe, is the default now. And getting your package to GitHub Actions generally means that you are putting your code like putting your code in a repository, like the distributable version of it, where GitHub Actions can read it directly. If you need to compile within every GitHub Action run, that's a lot of extra work that doesn't actually need to be done. So you could do that ahead of time, so every person using it downstream doesn't need to do that. But if we want to pull in Rust, that starts to become more complicated, because I think we could potentially try to run a Rust binary, but you're always starting from node 16. So having Node just bootstrap and run a binary is potentially an option. But the other option that we're looking at is, what if we can use Wasm and we can slowly remove or switch out pieces that make sense to run in Rust, but compile them to Wasm and have Node run the Wasm bit. That way it would be cross cross OS compatible. And that's the issue with the binary. If we have Node just bootstrap and run a binary, that binary needs to be built or run in a way that works across multiple operating systems, which you can do by detecting what operating system you're running and then running that specific binary. But that whole publishing scheme is so much more complicated, especially when you're doing GitHub Actions, because now you're having to bundle JavaScript potentially, and then binaries 2, 3, potentially more for every operating system that could run in GitHub Actions. And when you go to actually make that publish, you end up having to like run Rust in CI 3-4 plus times and commit that back, and like that whole flow just gets really complicated. So mostly what we're going to be focusing on today is what does it look like to pull Wasm into Node, um, and maybe we can try running it in GitHub Actions and see how things work out. But I think if we can run it locally, it's going to run fine in GitHub Actions. So, backstory out of the way. I want to double check to make sure that I got my audio stuff fixed. So last week we had Jonas on the stream, and we did a Tori Mobile. So Tori Mobile is in alpha. Go check out that stream where we got Android set up on Windows. But the first like 2 minutes I didn't have any audio because I was tweaking my audio routing to get audio to Jonas separately from what goes to the stream. And in doing that, I changed my devices, and OBS decided to change all of the reset the audio tracks that I was sending to. So we didn't have any music, and we didn't have any audio at all for the first like 2 minutes, which was kind of frustrating. But I think this should work now. Is it? I got too many things here. Oh, I don't have. No, it should be coming through. I don't even hear it either. That's what's kind of odd. So there might be something there. Routing, music. Let's reorder these devices. Yeah, we can. It's not a big deal if I share this, I don't think. Display. Also, the other thing, my Stream Deck just decided to reset all the OBS stuff. For some reason, all of my OBS buttons are just technology. Okay, so we want we got a whole bunch of sources here, which looks like you can see on stream. Audience FOD 2 and 3. I didn't want the Spin the Whale Stream Deck updated. No. For once, I just want stuff to work when I hit go. I feel like there's always been some random thing that just decides to stop working, especially the past handful of streams. So at least the mic is working, and I can see the mic working here, and my routing should mean that I'm routing out to the audience stream, so you should be getting both VOD and audience. And VOD and audience, but I'm not seeing any. Also, my headphones aren't connected, so that would be one reason why. I'll just switch here. Can you all hear the music? No music. It might just be too quiet. There we go. Okay, now I got it. That is. Okay, so now we should. Not seeing anything on that monitor. What in the heck? So VOD track should be getting the music. The music, whatever mix, music mix, I guess. Oh. Oh, that was loud. At least in my ears. Hopefully it didn't blow you all out. I don't know why the VOD track isn't coming through. I'm not sure why. Oh, now it just decided to start working. Okay. All right. How about now? Are we getting music? I think we are. I don't know why the VOD track was just not working, and when I swap back and forth to the audience mix, it just started working. And now I can actually use a little dial on my mix create, which is nice. Okay, I think we might be good. Distractions. Okay. Yeah, I think that's it that we need to deal with right now. I'll deal with Stream Deck later. Okay, so Wasm-pack. Let's dig in there. Interesting. So Wasm-pack is oh, so Wasm-pack is actually like a CLI. You install Rust, install this tool. Ah, I did not know that. Interesting. That's a little bit annoying. I kind of wonder if is there a search in here? Yeah. Scoop search Wasm-pack. Out of curiosity. Although they might also have it on their GitHub. Oh, that's the team. I was like, why is there nothing here? I could have sworn there was something here. So Rust-pack uses Wasm-pack, there we go. Wasm-pack uses Wasm bindgen. And Wasm bindgen is basically the thing that handles the bindings for the types and such between Wasm and JavaScript through Rust. So I think yeah, it looks like we're gonna have to do that. we're gonna have to download the thing and run it, which is fine. So let's go ahead and grab this. The other thing is, I guess they have some changes from last week. It seems like they've had issues getting help maintaining it. Oh, there's a Dino target now too. Interesting. Because I think Dino can run or import Wasm directly. I believe Node takes a little bit extra lift, which Wasm-pack handles. Okay. I like the icons. So let's go ahead and install this. We might need to refresh our shell to pick up on it. I'm glad though that is at least finally in a state that's reasonably working. What is it doing? Actually installing? I could run it again. I guess while we're waiting for that, so there's a bunch of commands: new build, test, pack and publish. So pack and publish does, it actually does a npm pack and npm publish. I want to do my own bundling because we're not actually like necessarily publishing this to npm. So I think mostly what we're going to be looking at is new and build. New being the thing that we run the first time. So we can just straight up start a template using something like this. No install, should not attempt to install any underlining tools. We're actually kind of fine with that. Normal, no install, enforce. Okay. And then once we've done all that, then we just build. And we've got dev, profiling, and release. So if we run build, then release is used. Okay. So if you don't actually specify which profile to use, it runs release. It is. Look at my green screen again. Okay. Oh, so this, it's not signed and Windows is complaining. Okay, successfully installed, sure. Now if we do Wasm-pack. Ah, okay, wait, cool. I didn't need to restart my shell. Now if we run new, do we need a folder? Doesn't seem like we do. So I'm gonna go ahead and just grab this. We're just gonna make a side project in this folder. I'm gonna say Wasm-pack test. Template is fine, and I want to do no install. Dash mode. Unknown build mode. No install. Okay. I mean, maybe it's specific about I mean, do I really need this template? What is in this template? Let's take a quick peek. Might not actually be something that's helpful. Yeah. I don't think we actually need that. Let's just use the default template. It really doesn't like that mode though. The Wasm-pack new project -- mode is no install. No install. I guess we're doing an install. Let's do this. Okay. It looks like it pulled that template that we were just looking at anyways. And it did put it in a folder, so that's good. I'm gonna go ahead and open that. We actually don't have too much here. Hello, kitty. If we do a Wasm-pack build, what do we get? And we can give it an optional path argument. And it needs to point to a directory that contains the cargo.toml, which is our current directory. So if we just run it, it should just look in our root, or like where the CWD where we're running it. So there's another -- mode no install. Interesting. Oh, were we looking at? Yeah, there's definitely a no install mode for new. Yeah, I don't know. Doesn't seem to be doing anything. Maybe it is. Maybe it's compiling and it's just not opening it. Come on. Just don't do that. That bothers me. Coming up? I got two kitties. Here we go. Here we go. Downloading component Rust standard. So that was one thing that I was curious about. Rust has a standard lib. I believe it has a bunch of operating system specific things within the standard lib. So if you're compiling for something like one of the more, I would say maybe eclectic targets, like if you're doing embedded, Rust embedded, then you start having to look at not including the standard library, which is definitely more involved than just doing a cargo build. Okay, so Wasm package is ready. So what do we got? So we import star as Wasm. So we're importing the Wasm directly. We are calling an alert, which I think, I'm actually not sure what that does. I am not sure what that does. But this is actually giving us all of the things that we like need to publish. But really, I just need. I mean, I guess these are nice. I could include the TypeScript, but I wouldn't need like the README and all of this. I mostly just need. Oh. Okay, so this is the, I believe this is the Wasm-pack stuff, where we have to do some conversions between, because we're going Java, Rust is being compiled into Wasm, and the Wasm needs to have the things that Rust is aware of. So like the data types and whatnot need to sort of be mashed across this Wasm layer. And I believe that's what this is doing. So I think essentially we don't need these like top 3 files. I guess the package JSON probably isn't a big deal. What do we have as far as, okay. Oop, oop, oop. We have a couple options. So we can output JS is suitable for interaction with bundler. You can import the JS, the module key is specified. Okay. And we also have this, which is common JS. Interesting. So it looks like this would be. Let's go ahead and try that web. And that would be -- target web. One thing I'm curious about is if it's going to update the folder. Optional fields missing. Okay. It's ready. Does this pull in new text decoder, uint 8 memory? So there's another thing that I'm thinking about too. Node has 2 subtypes, maybe you would call it. Common JS. Well, what module types? What are those called actually? But there's common JS and there is ESM. Common JS is modules, I guess. Module syntax. 2 types of modules. Maybe that's the best way to say it. I couldn't remember if common JS was actually still considered a module. ESM stands for ECMAScript module. Node module API. Common JS is sync. ESM is async. ESM tends to be more compatible with the web. I am partly curious if we compile to Wasm using the web flag, if we'll be able to use that in later versions of Node. So, did they switch the default? I honestly don't remember if they've switched the default now. Okay. We can use it to use. Okay, so the default still is common JS in. If we just pass it to JS, so we have no indication of if it's MJS or CJS. that with either of those extensions, we're kind of like telling Node, but we're giving a hint to Node to use that. We can also set a type, package JSON. But if we give no hints at all, it treats it as common.js still. And that's in version 18. So our expectation is that whatever outputting, unless we give it any hints, is going to be treated as common.js, which is fine. Okay, I think if we would try that, we would have to try the web. I don't think no modules is going to be the way to go. And I don't know that we want to do bundler either. You'll import the JS and the module key is specified. Oh, okay. So that's the other thing. When they're creating this, yeah. If so it's the type. So it'd be type module would be ESM. So if they're filling in the module, I don't think that's actually going to have an effect on how Node would require it. Where is it? Okay, so we set side effects as false. Which is more of a web thing, I think. I'm curious though. Well, we'll keep that in mind, and we'll play around with that flag once we kind of get something rolling. So this is actually going into the template. We've got some tests, building, and then testing. Interesting. So they've got like a whole web browser thing in here. Yeah, it looks like they can, at least they specifically say, oh, okay. So we can run all of our tests in Node. Run all tests which are intended to be executed in a browser. Okay. Wasm-pack test runner CLI. An experimental test harness for Rust programs. Compiled to Wasm. Okay. That being said, I am actually curious. No, I don't want to look at. Here. I want to see. So they've got Cargo Toml, which is using Rust Bindgen, which we hadn't mentioned. So like this is something to think about, and may or may not be an issue. Now, when they're outputting, like if we look at AppVeyor, this is going to be the thing that's creating a build for Rust. Travis, I'm guessing, is going to be Linux, and I think they can do Mac. I don't see anything specific there. I guess if they're doing something like Wasm, the whole deal is The only difference is the app fair is actually bundling it in an exe that you can install. Rust up in it. Oh, so wait, is that just tests? Yeah, okay, maybe that's just the tests. Oh, this is the Wasm-pack one. Okay, well, we want to look at pack. How are they publishing these? Because I'm curious if they are publishing, they're using GitHub Actions. How are they running it? I guess they're using Rust to compile the thing, but are they compiling like what's the binary that they're creating is my curiosity here. Okay, so they're doing x86 ARM x86 for Mac and x86 for Windows. So they're only doing an ARM build for Ubuntu, it looks like. And get a build. We are moving binaries. Okay, so here's our targets. It's an interesting way to do it. I don't know why they didn't just put it in here. Env release bin. Okay. Version env release bin. So they're setting the release bin somewhere in here. Version. Search for it. Is that just like a... Interesting. I wonder if it's this. I wonder if that's what's actually holding it. Set Rust flags, but this is only in Windows. So it's setting a bunch of environment variables here. I wonder if that release bin gets set via that. I guess to really satisfy my curiosity, Windows includes an exe, which is what we installed. I'm guessing the other things are tar zipped. Yep. Okay. Which Wasm-pack? So it is doing a Wasm-pack exe, so it does have some sort of binary that it's running. So it's not. I was curious if it was doing some Wasm-y thing itself to run. Okay. That distraction aside, I think we've got kind of an understanding of how it's going. I want to take a slight detour. We want to look at we we want to look at this. So we were talking, Emer and I were musing about what it would look like to start rewriting some of Covector in Rust. Specifically, this is a project that I've been working on for a little bit now. It's weird, I hit send, it shows up there, and then it actually shows up in my chat window in OBS. Man, the lag in the YouTube chat is real. So we were talking about what does it look like to swap out. The issue that we're having is we're working with a bunch of file formats: TOML, JSON, YAML, just raw, whatever file, just something that contains text, and Markdown. And none of the parsers that are in JavaScript that I can find edit things safely. So if you parse and then write it back out, it'll strip stuff out. So like with the TOML parser and writer, it will reorder things differently and it'll cut out comments and such, which is really frustrating. And part of the reason we were looking at Rust was there is a library called TOML edit. I believe TOML edit. Nope, that's not it. TOML edit RS. Here. That is the bit that we are specifically keying in on, and I think that part of it is Rust uses this, so by using something that is sort of adopted already by Rust, it's gonna keep that parsing in line. That's not necessarily going to work for other languages, which is unfortunate, but I think the parsing tooling in Rust is going to end up being more powerful. And I feel like we'll be able to keep things more stable because something with our Markdown parser, it tends to have breaking changes often, and I think it's quote unquote not really breaking because we're just modifying the like the structure of your Markdown document. Technically it's breaking, but I kind of feel like it's not considered as big of an issue. But when we're doing something like this, where we are writing to a changelog or we're parsing change files, that stability is important. I don't really want to be taking a changelog, inserting a few lines for a version, potentially more, but inserting some content for a specific version and then have version further down the line all change. Like, we want the content to be stable except for the thing that we're inserting. So TOML edit will take care of it for us, for specifically for words are hard. It'll take care of us. It'll take care of it for us for TOML, and we'll have to deal with JSON and YAML and Markdown separately. But this can sort of be the start. We have an extension point in Covector where we'd be able to swap these out pretty seamlessly, I think. But let's go ahead and clone this. Where's the clone button? That was right here. Upload files. Clone button. Where are you? Weird. Do they really just get rid of it on? Zoom in. Does it really just go away? Interesting. I think this is technically the mobile view, so it's sort of making a presumption that you don't need to actually clone. We're gonna do this. We're gonna say, I don't think I have a directory yet. Should I spell that right? Yep. Amr Bashir. Hopefully I'm saying that right. Okay, so, and it looks like he is specifically saying use the Node.js target. Oop. Ah, jeez. Made the directory and then I didn't even bother to go into it. I suppose I should make this a little bit bigger. Okay. Code. We got some code to look at. Now we have, as mentioned, we are taking toml edit. Okay. He's not actually doing a use it, I'll just using it directly. The expectation is that we're taking in a string, modifying a thing, and then returning a string. What's the path to do? Interesting. Package name. Oh, okay. I don't know if I would use that syntax necessarily. But what we're looking at here is if you take, so like here this is reading a cargo file, its own cargo file, which is convenient. And we're saying, well, we want package name, and we're editing the name. I honestly kind of feel like dot syntax would be better, but if we do Wasm-pack build target, that will give us a toml edit wasm node thing that we can specifically run. So right now this is written in CommonJS, and if you do a Wasm-pack build target Node.js, we could potentially try running this with ESM. So we could do, and the reason I am interested in ESM is because the ecosystem is slowly switching over, and I would prefer to be a little bit ahead of the game. Part of this is removing or otherwise flattening our dependency tree, because I want Covector to be extremely stable, and the less like transitive dependencies that we're pulling in, I think it will make that easier, because we're going to have greater control over that stability. Yeah, that's fine. So now if we would run node index.js, this is going to run it as a CommonJS, and it's okay. So it's saying here's a before and here's an after. Does it actually write it out? No. And we're specifically not writing out because my presumption is that if we include file operations, that's going to make the Wasm more involved. But I'm not sure what the Wasm spec says as far as does browser. The browser doesn't presume file operations. So, did it? It didn't send the other one. What is this, chat? Apparently, if I send too many things back to back, it just straight up doesn't work. Oh. I'm not very smart about my word wrapping either. Interesting. That is going to be to do. It's cutting it off. So like I need to actually just like straight up wrap it and say something like, oh, well, I just sent it again. Oh, well, whatever. You know what I mean. It's cutting it off. No bueno. I'm gonna have to fix that. My presumption is that it's going to be easier to package a Wasm file and use it in a cross OS way if we do all the file operations as triggered through GitHub Actions and Node.js in Node.js. So if we are strictly just taking a string and mutating it and returning a string, I'm not sure how Rust or specifically through the Wasm-pack, if it's actually like, if we look at this, we're taking a string. I think it's doing mutations, but I don't know if it's mutating the value in memory on the Node.js side. So I think like this ends up from our Node.js code. It ends up, I don't know if it actually ends up feeling like, or if it actually is completely functional. Like what's the word I'm looking for? Immutable function. Immutable? That's an open question. But what we're doing here is we're just writing out the before and after so we can see that it's actually changed it in a way that is still preserving the comments. Interesting that the before doesn't have that comment in there. Why would it not have that comment in there? So it is taking readsync file UTF, and is straight up logging out that file. So it should have this comment in there. Weird. Index.mjs. I suspect that there's a question there, and I can make a presumption. But if I could ask you just to restate it. I have two. Yep. We had kind of mentioned it before, but the index.js, that presumption is common.js. Which am I running? I am running just .js. So no worries. So the index.js is running it with the expectation that we're running in Node.js through the Wasm bind gen, or excuse me, Wasm-pack target of Node.js, which outputs common.js. I'm also curious about ESM, which is why I copied and made a MJS. But we haven't gotten to that yet. It does seem like the comments are preserved. When we log out this after, we are getting the comment, which is expected. But what is really odd is straight up just reading the file and then logging it out. We don't include the comment, which is very confusing to me, especially since we're sending that value through. So like that file has to have the comment in there because that's what's going to Rust. So like there's got to be some way with the way it logs it out. Is it just losing? So I don't need to build again. Yeah, like it's just. Is it something with the console .log that it was it process.write? Process.standardout.write, and that can take a string or a uint array. So we should be able to do this. I wonder if there's some like formatting or something that's happening in that. Oh, not standard in. Ha. I don't know why that comment is just disappearing. That is just. That is very confusing for me. Okay, now it's there. See more key. Before, right? I was looking at the right thing. Yep, before. Not there. So was it with some like. Now it's there. If I take out this. Okay. Man, terminals and shells are weird. This could very well be a new shell thing too. So it's not there. If I add in new lines, now it's there. Okay. My. I did goof up. Oh, I did goof up the UTF-8 stuff. Was that it? Is it just cool with no. Yeah, that is wild. If I literally just add in new lines, then it starts working. Out of curiosity, yeah, there's something odd going on there with how it's writing it out, but it is there. The content's there at least. So I think this is fine. Let's rewrite this real quick and do it as ESM, and let's see what it's doing. Can you comment the edit call? Can I comment the edit call? Oh, just like straight up remove and don't do the edit. Try that. Yeah, so like I think it's something with the, I think it's specifically something with the after and with this like the UTF, or what is that, the coloring syntax? I don't remember what that's called. So like if we strictly just do this and say console.log before, buffered IO. Can you say more? I don't feel like there's enough. Yeah, can you say more? Like is it you're thinking that it's literally writing it out so fast that we just like lose a couple lines in there basically? That would be just wondering if you're clobbering the buffer before it gets flushed. Okay. Yeah. That is very interesting. I mean, we could very well just do something like this, where we go how do I want to write this? I guess I do this. We could do the formatting too. I don't think it's the formatting. I think you're on the right track. I think it has something to do with it's just effectively like writing it out so fast that it if I'm understanding what you're saying with clobbering the buffer, I still would expect this to work then, right? I think I kind of understand where you're getting at, but that works. So are we thinking, when you say clobbering the buffer, well, the way I'm reading that, add a flushed before the last log, maybe. Oop, I still have one in here. If we were having an issue with it being flushed, one console.log I think would fix that, right? If I believe I'm understanding what you're saying. If we do everything in one console.log, there's a single log and we don't need to worry about that issue. I mean, this is a little bit of a distraction, but you know. Is that not gonna help me out here, are you? WebGL. I can't remember if that's a function. Oh, no. This is still in there. Because it was specifically when they were back to back. Do I have... No. I think that flush... Is that flush the thing that's adding that new line? I think that's doing what... I think I'm doing what you were hoping for. Yeah, not important. Just a weird problem. The console.log for Node is not V8, so yeah. I'm wondering if it has something to do with this syntax and if there's something slightly off about it, to where like this ends up basically like overwriting previous bytes, and if we put in a new line, because there's like, I don't know, you can add bytes, you can remove bytes type syntax. I don't remember any of the terminology offhand. I don't do that directly enough to know. But yeah, that's, yeah, interesting. I mean, this works fine. I think I'm just gonna leave this just so it's a little bit clearer. And we're not gonna run into that bug. I think if we do this, it does not work. We don't get the comment in there. If I take this little bit out here, we still don't get the comment in there. Is it this then? I don't know. Something is funky there. But whatever, just minor distraction. I'm going to just copy this over here. Let's try running this in ESM. We are going to have to rerun it. Cargo toml, UTF-8, file edit, new name, edit. And we'll have to run our Wasm-pack with... I don't think I want the bundler. You'll import the JS and the module key is specified. I think that module key is specifically a Webpack thing. I don't know that anything else actually pays attention to it. Yeah, off the top of my head. This you'll import the JS does have me curious, but I think I really want like native ESM. And I think the browser version will actually run in Node.js as well, but we will find out. If we look at what we get out, doesn't look particularly different. We don't have, what is this? .ts, yep. So we only get one import, or one file to import, and everything is in there. There are comments. I think those are fine in, yeah, like this is just js.comments. I don't think that's gonna be an issue. Well, it's definitely not an issue in browser, but it's not gonna be an issue in Node either. So now if we run that, we can do Node.js or node index.mjs, and that's gonna specifically run ESM because the MJSs, giving the hint to Node to run it with that. Okay, cannot find module imported from that. Not something we can't work around. Okay. Named export edit not found. The requested module is a common JS module. We can try it. Toml edit. Yep, okay. Toml edit. Let's check out what it's exporting quick. It is doing an export, and it's exporting in init, and then it's sync. Init grabs the Wasm, and it is very clearly using ESM. We can also do init sync. We should have top level await. I might need to actually toml edit promise. I might need to initialize it myself. So once we get it, we call finalize init, which is going to give us the module. Yeah, so we might have to actually do an init, like a wait for an init first. Unexpected token export. I mean, yes, we are. Interesting. So it's not actually setting the type. Module. So if we do that, okay. Read file sync. Of course. And we can do from fs/promises. And we can do read file, and we should have top level await in here. We are on Node version 16, so right, Node version 16 does that, or does top level await. Read file sync is not found. Yes, of course. Okay, we are logging out. And we need to now await this, which is not defined. Yeah, so I think that's probably going to be the thing that's going to catch us if we do the web, because it's expecting to be loaded in the web and do a fetch to call this Wasm file. So I don't think we're actually going to be able to use the web. Same as web, except JS is included on a page and modifies the global state. It doesn't support as many Wasm bindgen features. Okay, let's try the bundler. It does say we can do an import. Bundler. What does that look like? We get an extra file in here, whatever .bg is, bindgen. So our main file is much smaller. We are doing imports and exports, and it's doing import star. And then this, I think, is basically like initializing it. we look at, if we search for this, nope, in here, please. Okay, so it's exporting Wasm as a function. And then it's attaching export function edit. Is val. Ah, okay. So we're doing two things. We're okay. So we're passing in the Wasm file directly, and then that Wasm file is, or that the node wrapper is taking that as input and setting the value equal to Wasm. So now we have Wasm like initialized as that variable, and then we end up doing things with it, such as wasm.edit, which is the function that we end up calling through this like Wasm bindgen layer. You can see malloc and realloc. And we do some Wasm things to take data type representation from Node into something that Wasm can understand. Toml edit. So I think this one might work. Oh, what do you got? Cannot use import statement outside of a module. That is also not setting type is module. Unknown file extension Wasm. Okay, so this was the part that I was really curious about. I think there is a flag in Node.js to run using Wasm. So if we're importing Wasm directly, where is that? Node run Wasm. Assembly script. Interesting. So here, like, this is effectively doing like reading it and then initializing it. And here, WebAssembly modules cannot directly access OS functionality on its own, which is kind of a feature in the case that we're looking at. If we do all of the OS functionality through Node, Node is going to be our layer that works across operating systems. So as long as you can run Node on whatever operating system you're working off of, then it'll work. Experimental WASI. So there's WASI and there's Wasm. WASI is, I think, different than the Wasm thing. Oh, maybe it is the same. Yeah, okay. Yeah, no, I think you're right. So there's Wasm, there's also WASI, which I think is a special WASI. I thought there was a group that was doing, is it Wasm time? Is it just that they have their own wrapper? Wasm time supports through the WASI standard. Okay, so maybe that's it. I was thinking that Wasm time was the thing that was setting the, or like WASI was specifically related to Wasm time, but it's using WASI. And okay, so this is running. This is basically running the Wasm, which is what we're looking for. So if we do to compile what to Wasm, okay. I don't really want to do a no, it's this. Okay, so what is the compiled version of Wasm, I believe? Translate from binary format back to text format. Ah, okay. What, translate from WebAssembly? Ah, okay. No, I had it backwards. What is WebAssembly text format? So WAT. And that's like the human readable version. When we're running Wasm-pack, we are getting the binary version. Okay, so if we are running is that the flake though? Is that the flake that we want? Experimental WASI. I mean, what's the worst gonna happen? You can just try it, and if it doesn't work, it doesn't work. Yeah, unknown file extension Wasm. But that's specifically doing this read file. So it's possible that we could get it to work. WASI. WASI get import object. So it's possible that like we could get this to work, but Wasm-pack is only outputting common.js, the bundler, or the web version, and the web version includes the fetch. And the, I guess theoretically we could use Node 18 because I think that has native fetch now, doesn't it? But GitHub Actions is using Node 16 still, so that would be an issue. And I kind of would still like to support Node 14. Because I think it'll just make things a little bit easier. Okay, and they do have a CSGS and ESM. So I think we'll be able to do ESM eventually, but it looks like what we're getting out of Wasm-pack is probably going to only work with common.js. It's at least the feeling that I'm getting. Which is, it's fine. It's not the end of the world. I am curious. You'll import the JS and the module key is specified. For something like Covector, we're running all in Node, basically running it like a CLI. And in GitHub Actions. I suspect probably the Node.js is going to be the best way to go. And it is currently common.js, so like there's no way getting around it. The benefit of ESM, if we would happen to convert over, is that ESM can still import common.js. So even if this stuck around as common.js for some time, it shouldn't be an issue. As long as the like main wrapper of the thing running this is ESM. This could be either CommonJS or ESM. So it probably makes sense to just stick with CommonJS and roll with that. So that being said, what we're doing here is we're basically taking a path and then we're replacing a key and failing if we can't. We could change this API a little bit. This is like, we could potentially just call it multiple times. It's not the end of the world. As far as what I'm looking to do though, I think we basically end up taking a file input and then an object, I think is kind of what we want to do. And we can use that to, the object will be both path to a variable and then the variable value. And that'll let us change like the main version number and dependencies. Because I think what we'll end up doing in Covector is building up an object with these values, creating a new object with the updated values, and then taking the string from the old one and just updating the string, and then we'll feed it basically that whole object. You know, here's an object with all these values, map it and replace it. We may end up doing a little bit on top of this and keep Toml edit this Wasm integration more of a take variables and replace them, whereas in the object that I'm passing to this, I kind of want to just pass the version number wherever it is, just update it, because as far as Covector is concerned, it's just a version number and then it's dependencies that have version number updates. So I think there's, I guess there's going to be two situations that we're editing. We're editing either the version or the dependencies. And I guess it probably makes sense to just keep those as separate operations. Yeah, I think so. So I think we learned some things. We are able to use the Wasm directly. Do we have, let's close a bunch of these tabs, we don't need them all open. Okay, so currently it does not have any GitHub actions in here. We could potentially try running this in GitHub actions real quick, just to see if, what would be an easy way to do this. Yeah, I guess if we want to make sure this works across operating system. So let's do how do we want to do this? We'll make a fixtures folder. We should be able to knock this out real quick here. I'm going to remove the MJS because I don't actually need it at the moment. Writing it out is fine. We want to take a cargo Toml fixture, and this then ends up reading fixtures. And I think what we're going to do is we're going to how should we do this? Let's do a check.js. This is very specifically going to check if one thing matches another thing. And I think we just write it out to like a temp directory or something like that. So we'll do file old, file new, and we can do an assert that file old is file new. Assert value. Okay, so if we would do a Nodejs check.js, read file sync is not defined. Yes, it is not. You are correct about that. So that passes the files match. And now if we run this again, we're going to get an error. And in this case, we don't actually have the file created, so it's going to say, that does not exist. So if we do a read file in edit, that will give us a new string, and then we can do a write file sync. And that is going to take a, this looks like a file path. Might need to actually make this directory first. Cargo.toml. Yeah, I think that'll be fine. File edit. And I think it's a make dir sync. Yep. Dot temp. I will just make it every time. I don't think that's going to be an issue. My ID already imported these things as well, so those should work. And now if we run index.js, oh, we need to repack it. Target Node.js. So we should get a new pack. And now we run this. It makes the edit. We get a temp directory with a cargo toml with a new name. And now they should not be the same. Okay. What I'm actually going to do is I'm going to have two fixtures. I'm going to have a cargo old. That was supposed to be an underscore. Then we'll have a cargo new, and we will basically manually just write the difference between them, and then our assert is going to assert on the new one. Yeah, that'll work. So then this one should be running it out to .temp. Check should be on cargo old, and no, cargo new rather. And we're checking it versus the temp that has been created. Cool. Real like low level test here, but at least we are confirming that what it's doing is working. And then we can do do a compare, and this is going to be a good indication of what has actually changed. So we could also say, let's change the version to 1. And this is not going to pass anymore. And I kind of wish it would tell us the diff. That would be nicer, but I'm not going to bother trying to implement that at the moment. And we are doing we're doing this. So if we do as it stands right now, we basically end up having to like chain these together. So we have file edit 1 goes into here. This is going to be version, and then the value is going to be 1.0. And then what we write out is this. File already exists. That's fine. Is there a cursive? I thought there was a way to just like not error if. I suppose I could just throw a try catch in there, but FS file system, where are you? File system. So write file into the encoding. That's it. And make directory. So the mode is not supported in Windows, well that's annoying. And recursive false. Okay, well, we're gonna wrap it in try catch. So we're just gonna say try it. Catch error. No, not console.error. All right, and then we can do a check, and they match. Cool. So now we can throw this in GitHub Actions real quick, and I think that's probably going to be. I think that's probably where we're going to be where we're at. Let's do a git remote. I don't believe I have access to. All of the like options disappear if you zoom in. So I guess I'm gonna fork. We're gonna do a git remote. I want to rename git remote rename old new. So origin should be upstream. Git remote. No. Git remote, not remove. Okay. Now git remote add is name and URL. So git remote add origin. I am going to do it into my own personal. That's fine. and this. So now I should have a get remote for upstream and origin, and now I can do a we have a couple edits here, so I can do a get. We're just gonna go right to the main branch because it's not worth trying to do PRs across forks and such, or it's not worth PRing to my own fork and then doing the same donmers. So we are going to just commit it directly to the main branch. I guess actually master branch. The what should we call it? Add Jeep test. Add. We're gonna say low level. Low level test. Grab stage. Again. And then we'll add a GitHub action. Is there a can we init GitHub action from like the GitHub CLI or something? That would be kind of cool. Workflow. What do we got? Enable, disable, run, view. No. GitHub action. You know what I'm actually gonna do? I don't mind copying something existing and just stripping everything out of it. Honestly, like that structure there kinda is helpful. At least the way that I think about things. And I'm familiar with GitHub actions enough that it's not going to be an issue. Workflows. And let's call it just test.yaml. So they've got Linux, Mac, and Windows, which should be fine. Test, we're gonna do it on push and pull request. I guess this is, well, we've already committed to the main branch, so shrug. Checkout 3 is fine. Set up Chrome driver. I don't actually want the Chrome driver. I do want the tool chain. I don't know if I'm gonna need. I think it's gonna handle that directly. I do need Wasm-pack though. And that is going to be how might we get this? Test, maybe test. Favorite applications with Webpack, npm browser packages. So like we will need, I guess we might need to actually. So we'll leave it in there as our target. Now, is there, how are they getting it? So they're running a test here. Prove. Oh, 50. So this is just the book, and then release, would it be the actual release? And it is straight up creating all the binaries here. Release Windows, tarball. So this is uploading a whole bunch of stuff. It creates the download. Here, it creates the release. And actually, I think this action is in maintenance mode now. But it creates the release, downloads all the binaries that I made, and then it uploads them all to that release. Interesting. So it's querying the last tag. It works. So how do we go about running this from CI? Mvlogger, nifty. Because we're gonna need Wasm-pack in. We're gonna need it for every operating system effectively. I guess we could do like an install. Is it actually doing any? You basically just compile it ourselves. I mean, that's definitely not ideal, but like we could do it. This isn't I don't know this is actually thrown up on creates.io either, so we would have to do like a get reference. Which is maybe fine. I mean, we have get tags, so like we can peg it off the get tag basically. So if we do it like a cargo install, we can do get URL to install the specific crate from. And if we point at this, we're gonna get Wasm-pack version 11. Oh, yeah, I guess it is. Here, and there's a tag. So like we could do, let's give it a shot. It might end up conflicting with cargo, with our currently installed one. Cargo install -- get this -- tag is 0.11.0. I think get is going to give it, yeah, I mean it says URL. I'm pretty sure cargo handles GitHub URLs. We can do install only the specified binary. It doesn't seem like it actually exports a, or it doesn't have a bin set. So when it runs, cargo build release target. I think, yeah, we'll try it. We'll see what happens. Failed to find tag. That's not a big deal. Because I bet it's actually got a V in it. Updating GitHub repository. Binary Wasm-pack exe already exists in the destination. Okay. So if I do editor remove, I am going to uninstall it real quick. This is why it would be nice to have it through. Again, I'm not a huge fan of just releasing binaries themselves. It ends up being really hard to update, like just keep maintained. Pack. Not seeing it in my list. I'll check out Winget just on the side here. Unfortunately, it takes a little bit of time. Could do an overwrite. Maybe it wouldn't be the end of the world. But I really don't feel like goofing something up and it just the install being messed up and then nothing works. Wasm. I don't actually even see it installed. Interesting. Oh. We're going for it. I mean, we've tried everything we wanted to try. So like worst case scenario, I bark it and then it's just not gonna run in my system until I fix it. The stream will be over, so no big deal. Got a bunch of crates. So we can basically run this from GitHub Actions because we're going to have cargo installed already. And we can cache our dependencies. And it's fine only changing them if our cargo lock changes, because our cargo lock is going to change if we update dependencies, of which we would also want to update the thing that we're installing here. Cargo install --get --tag b0110, and then we end up doing a Wasm-pack build. Target is Nodejs. Oof, this. This open SSL stuff might be frustrating to deal with. Process did not exit successfully. We'll try it in CI. Worst case scenario, it doesn't work, and then Shrug. I think we're going to be kind of SOL at that point anyways then. So node index.js and run node check.js. I think we could probably put the backtrace on there. I don't know that that actually matters. And I think potentially we could run, because so the Wasm-pack also has that built-in test runner, so we could like theoretically use that, but this will be fine for the moment. We mostly just want to see how it's going to work across OS. That's kind of the main thing that I'm driving at here. All right, let's give that a shot. Add test workflow. And then we'll push it up. Whoops. My origin is get remote get status. I'm probably tracking the upstream, aren't I? Get get push -u origin head. Can't remember if the head is. Yeah, that should work, I think, right? So now we should have, there we go, add test workflow, and we got test running. Sweet. So we'll see how this Wasm-pack goes. Hopefully that install works. If not, well, I think that's kind of where we're gonna end it regardless. I'm hoping that it'll end up working. The ideal is that I guess in reality what we want to do is run Wasm-pack once if we run it just in Linux and then we save those values for the artifacts somewhere, I want to pull it into every operating system and test it across platforms. So this is actually, I guess it's actually not going to test exactly what I was hoping for. Because I want to make sure that whatever Wasm I'm creating is actually going to run on all the operating systems, regardless of which operating system I build it on. Let that run. Do we try to do that right now? Upload. Oh, we should be able to do. Okay. It's not opening up the stuff I wanted it to. Wasm-pack. Close, 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 close. Okay, they're doing a bunch of artifact uploading. I think we can basically do the same. Then we can get a, then we'll upload it and then we'll download it again. In which case we've got a test and we've got a build. Name build runs on Ubuntu latest steps. We're gonna do a run, and then we're gonna do an upload, and we're gonna upload the package directory, and then we'll end up basically unzipping it to the same spot. Why is this? That's not what I want to do. I don't know why it's set indent. I want 2 space. Yeah, whatever. And we want to run this. And actually, I guess this also we want to put in here. I mean, I think technically that's okay. Ugh. All right. I don't know why its formatting is so weird. I don't even think some of this is valid syntax, but and key is there. Oh, those are fine. Okay. So we upload the zip to. What is this saying? Unable to resolve action. Interesting. It's kind of surprising that none of them are found. I wonder what extension that is. I haven't actually. If I had that extension installed, maybe they just like default installed it at this point. I could see that. I actually do need this as well. Okay, so this should upload it, and then we should be able to download it in the exact same spot, and then it should be able to run on everything. So this is straight away downloading and uploading it again. Upload zip. I think artifact upload actually does upload a whole folder path. Let's confirm that real quick. We'll on the way there we'll check on our tests. We are getting an install, so it seems like that's gonna potentially work. So that might be the easy way to just get a Wasm-pack to run in CI. Not a huge fan of having it built every time, but is what it is. Now if let's double check this. github.com/actions upload artifact. Upload, we can upload an entire directory. So we would do the path to the directory. So that'll be fine. So that's going to give us the full package directory. And then on the other side of it, we name matrix targets. SAML edit package. They call it actually. SAML edit Wasm package. And I think it does upload it as a zip. And then if we download artifact, where does that get put? Download artifact. So we give it a name and a path. Name and a path. And does it unpack it? Download all artifacts. All artifacts will be downloaded. Okay. To differentiate between downloaded artifacts and directory. Ah, so I don't think it's actually zipping it anymore. It used to zip it. So I think we can do this, and we'll find out pretty quickly if that's going to give us an issue. Let's double check these. Okay. The subcommand build was not recognized. That's the thing that it errors on, right? Right? Okay. Well, it's fine. We got this updated. Git commit. Build on Linux, test on everything. Go, ship it. I am oh my goodness, okay. My brain is not working as fast as my fingers are, I guess, or vice versa. Push. Okay, so that should give us hopefully one last test that hopefully passes. So we gotta build. Oh no. Needs build. We are going to amend it. We're going to push it. I didn't actually have to do the force with release, but it's a habit, which I don't think is necessarily a bad one to have. So now that should give us the build being a prerequisite of test. So we should be able to get one build off of. Oh, it skipped. Oh, okay. Toolchain input was not given a Rust toolchain file. Matrix Rust. Stable. And in here, I don't actually need any of. Where's operating system OS? Okay, so I don't actually need any of this stuff. I think I'm gonna do this. So don't end up using any of it. And let's just double check that Yeah, so we got the key here. I'm gonna just straight up take out the cache. I think that's gonna end up, for this quick prototype test, it's gonna end up impeding us. Amend again. And my new shell, for some reason, doesn't recognize force with least as an actual command. So that little caret in the front of it is to tell new shell to just ignore it and go. Don't like pre-process it. So new shell does some, when you write in commands, it'll try like the new shell scripts first. And there's a git. There's like completions, but I don't know if that's, I think it's still, I'm pretty sure it's still running like the underlying git that you have installed in your shell, but it does some like command passing stuff, I think. So if your, whoops. There, that's looking better. If your completions or whatnot don't cover the full breadth of what your local or your installed git can do, then it'll throw an error, even though it actually shouldn't or doesn't need to. So I might just need to like update my completions or something like that. We did a stream a few weeks ago now, I think, on getting your dev environment set up. And I actually, so this is new shell in Windows Native. On stream, we set up a new instance of WSL. I had Ubuntu 20, I hypergraded or added a new Ubuntu 22, and set up new shell and everything in there, including hooking it up with Chamois. So my Chamois and WSL and in Windows Native, or Chamois will sync through Go templating my config for WSL and in Windows Native. And we had a stretch goal of updating Mac as well, but we didn't get around to it, so still need to do that. Well, I hope this works. This cargo install takes a bit of time though, unfortunately. I think it ran 6 minutes last time or something like that. Well, that one aired off quick. This one, I was looking at time ago, not the time of run. Yeah, so 7 minutes it took last time. So we got a hot minute. We can go. Here we go. Share. You can drop a link in the thingy. It's interesting that it's a live share link. I guess probably it doesn't matter either way. I think actually that live share link goes to the version with the chat. Does that come through? No. Okay. Otherwise, I think if you does it keep it if you refresh it? Yeah, it does. I feel like the live stuff on the live stuff in YouTube it's kind of an interesting integration in how it all works together. Like, it seems like some videos are technically live, but if you go to a different link, you don't actually get the live chat, so it doesn't look like it was live. I don't know. All right, 4 minutes in. We got 3 minutes left. So I think this is gonna work. As far as the whole point of this was to get something sort of like tested out and spiked out. And Amber helped us with kind of getting that set up for Toml edit. But if we can include it in here, because we have, I think most of it happens in this package. We have a bunch of switches based on the file name that will Toml parse or JSON parse or YAML parse. And here we're just looking at a straight string. So like any file with a string in it, that'll have the version number. So that's sort of the fallback if some of the package managers don't actually put version numbers anywhere in, like on the file system. Some of them will just store it via like git tags. And then we end up using that. So we get like we get the package and then we stringify it to like dump it back out. And see, like this has been an ongoing issue with like every one of these. They end up not safely editing it. So like here, we like the spaces in the YAML. That makes it easier to read. But when we write it back out, oh, and it looks like Zoltan did some work. They're the maintainer of PNMP. Zoli forks. Nice. Oh, hey. So like that's a possibility, but the problem is like anytime that these forks and such happen, I feel like there's a subset of people that are interested in making a library, and then when you have an issue that like and it gets forked, you slowly get a further and further subset, and then like which fork do you end up relying on, and like are they going to touch it for another? The PNMP folks probably would roll with it fine, but okay. So download Linux tarball. So is it putting in? It was downloaded to this. Toml edit. Okay, /packaged. Okay. Yes, so it ended up putting it in an extra directory. That's unfortunate. GitHub.com/actions download. So we gave it a path. Oh, we can look at the artifacts. So we should be able to say, if we go to the summary, yeah, so we get just like basically like a zip file, and when we say download, we end up saying like we want to download that. OGS actions. Oh, I bet you some of these are I think there might be a v3 of that. So like I don't actually specify Node.js, but I think setup node has. Yeah, and then there's some command deprecated stuff that's fine. And I think that's all potentially in setup. Okay. They do actually mention it here. We're probably gonna end up running this again, so let's just do that. I'm guessing it's the next version. Now, download artifact. We want the path. So that's output. If we name all artifacts that we downloaded, so if we don't specify a name, it's going to just straight up add an extra directory in there on us, and that's what happened. All right. So here's the name. So that should give us all the files in the directory, in the package directory. Was there anything else that I don't think so. We're gonna just amend this again. I don't really feel like I need the tries in between. Okay, we'll wait for one more run. I think however it turns out, we'll call it there. But until then, just noticed the heart was showing through my headset. I thought it looked weird for a second there. So I think this is gonna work, and we'll be able to. The way we have this set up in Covector specifically is that we have these like separate parsers, and they all happen to use like external parsers. So right now, toml.parse is this is a fork of another toml parsing library, but all of these, because it's just the two, but I think json.parse doesn't do like the safe parse and write. So like there's that issue, but then we also have the markdown, which is I think primarily in the changelog package. So I think it's going to end up making sense to, I think it's going to end up making sense to basically end up adopting this part of it. And what we're doing is very specifically focused to a situation. So we can, we don't necessarily need to make something that's going to work for everybody or be dynamic. We can write some code that's going to take some variables and like write them out in a safe way and just be done with it. And with our changelog, we're reading, we're doing a little bit of parse on the GSYAML up on the top. And then we're taking the content and using that in the changelogs. And the changelogs, we're just like inserting in into a specific point in the AST. So we're like building up the values and the content, and then like writing it to a specific spot in the changelog. So a lot of that is just like file operations and parsing. So we can probably just swap out a bunch of that for these like little Rust utilities. And if we're only operating on like string in, string out, and no file operations, I think we're going to be pretty safe to have our output in the action. If we go over there and look right now, we get a dist, and that is using a for cell thing called package or NCC, and that creates, it takes all of the code and the dependencies and puts it into one minified thing. So the difference or the addition that we'll end up seeing is we'll have a Wasm file here, and I think that we'll end up effectively writing, I think we will write one package that just handles all these different situations. So then our dist will be in index.js, and then like file safe file .wasm or something like that. Because when we end up packaging these, I think this is also going to end up including all of the extra JS that comes out of Wasm-pack. So I think it'll end up including like this and this. And then the only other thing we'll have there is the like .wasm sidecar. I believe is what's gonna end up happening. But it should, if oh, really? I guess they just released it as a patch. But I wonder why it's calling it out. Okay. It's interesting you choose toml to read. I was using a node config popular package in the toml node module, which has issues. So the reason, this isn't a config thing. This is, maybe use Rust Wasm to read toml. Yeah, so this isn't the reason we're reading all these different file formats, it's not a config thing. These are like package.json or cargo.toml that we're reading. So each, and the idea is that this can work with multiple different languages, and each language has a way to package its like version number / dependency tree. And some of them use like git tags, some of them use like contain it in some sort of file format. And within that file format, we end up having dependencies. So if the intent of covector is to give in markdown files that describe a change, so patch, major, patch, minor, major, and a config file telling it how these packages are interrelated. Bump both the version number appropriately versus based off of whatever change has happened, and bump the dependency versions. So like it would be less of an issue if we were just editing like the version number. We could maybe do like a regex type thing in string replace. But that gets a lot more involved with the dependencies, because in package.json and the node ecosystem, we got dependencies, we got dev dependencies, and then we got pure dependencies. Mostly we're just caring about dependencies because when we're publishing a package, that kind of ends up being the thing that you care about because the dev dependencies matter less. But package managers are starting to use that dev dependencies in the lock as well. So you kind of end up wanting to up bump the dev dependencies as well. So to your thought, it's interesting you chose toml to read. Yeah, so there's a few packages out there that can read and parse toml, but none of them, at least in the node ecosystem that I know of, do it in a safe way where you read it and then write it out and you're not losing any of your like formatting or ordering or anything. But this is the reason the toml edit is nice, and the reason it exists is because Rust uses toml, and within I think cargo edit, which I believe has been upstreamed now. It used to be like a separate crate that somebody wrote. The idea is that they wanted to do like a cargo add to add a dependency, but they didn't want to like strip out all of the comments and everything, and they didn't want to like reorder all of your like your package contents or whatnot. So that's what created the need for this like safe toml edit. But I don't know what we're gonna do about YAML and I don't know if there's a safe YAML thing. I haven't found one in Node. And I don't know if I've looked at one in Rust. YAML safe Rust. We could potentially try to use that fork that Zolt handed. But the idea is that we want to be as low touch as possible. So we're reading ideally and theoretically any file format that with a caveat, any file format that would be the thing that represents like package metadata or workspace metadata, and that, so we don't need to worry like about like binary or like proprietary formats or anything like that. It's generally very much like sort of ish like one package file type per language. So I think right now Covector supports JS or Node, Rust, GitHub Actions, so YAML, and Go technically with this like special. So Go tends to use tags for publishing, so they don't actually have their version number specified anywhere. But if you just put version number in a file, we can read that and use that. We could theoretically use the git tag, but it's kind of limiting, and it gets complex, especially if you're in a monorepo. So if you have like a polyglot monorepo, that starts to get kind of finicky. So you're in your case, you're mostly Node and you're trying to get Rust involved and learning Rust. Yeah, and that makes sense. So to your here, let's double check to make sure that that we're actually running while I'm talking. Okay, so we got some tests. Oh, I canceled them all around the same time. I do not want them to cancel though. Why is that running with PowerShell? What did I build? Include runs on Matrix OS. Ubuntu, Mac, Linux. This is test Linux stable. Why is it using PowerShell? Runner image, Windows. Oop. Windows. What? Okay. Do I have I think I have a cross OS. Oop. I mean, that should be fine. But I don't understand why it's here. And fail fast is the only thing I don't want to fail fast. Is that on strategy? Test strategy. Strategy, fail fast. I mean, okay, fine, whatever. I'm just gonna copy this whole thing just to make sure I don't. Because I know that works. Yeah, that's weird. Okay, let's just get this go again. I don't know why. I mean, I don't think it tries to run everything through Windows Server. Unless something has changed since I last was paying attention. Alright, let's give this another shot. Okay, to your question. And slowly getting Rust involved. So there are a few ways you can pull Rust in. Wasm-pack is one. That tends to be the way, and it's, when you say going mostly Node, I'm going to assume that you're running more like backend server type thing. We were looking at it a little bit before. Wasm-pack can create a bundle that is browser specific. That works in the browser. So your browser can run Wasm, and it still needs, I don't think it can run it directly. It still does need a JavaScript wrapper, so you're never going to completely get rid of JavaScript. So you need it at the very least to run in the browser, a little bit of JavaScript to bootstrap the Wasm. So like you could technically do like a whole app in Rust, compile it to Wasm. Up to sure, yep. Do a whole app in Rust, compile it to Wasm, and then run the Wasm in the browser. They don't really say anything about that. But you end up getting basically like a Wasm file in the browser, but you still need a little bit of JavaScript to like bootstrap the Wasm bit of it. So you could have literally your whole HTML set up. You can do like a little shell of HTML, little shell of Rust, or excuse me, of JavaScript, that then bootstraps Wasm, and have your whole app be client-side rendering in the browser. Oh, Leptos can do server-side rendering too. Cool. There's a handful of them out here, but Leptos is just one that I know offhand. Chris was here earlier in the chat, and I think Chris has done a couple videos on Leptos and uses it on a site or two. So that's one option. If you're doing browser, you could go like full Wasm theoretically, and pull in Rust that way. If you're doing more like Node backend stuff, I think using Wasm is much less common. There was a project called Neon. I was hesitating because I couldn't remember if it would show up with RS or not. This one was around for a little bit. I mean, it's still around, but it's been around for a while. It hasn't quite had as much attention as I'd hoped it would. It's not an easy thing to like work on. So like I completely understand it. It's sort of like a thing that's needed, but it's like thankless work almost. And I don't think anybody. I think this was more of a side project for people than it was a necessity for like a business or whatnot. But this was sort of the way to do it before NAPI came around. And we'll get to. Actually, I guess we could do that now. So neon bindings, I've used this before and it works fine. And this ends up going. You get sort of this like Wasm bind gen style thing as well, where you have these like bindings to JavaScript data types within your Rust, and you're doing the same like pass back and forth. You're doing the same like you import it and then you can use it just like you would any other JavaScript package. And they don't really say it anywhere up front. I feel like they had a lot more docs than this. API reference? No. They used to have a lot more docs, I feel like. There's a whole like publishing section that's missing. If you're familiar with gosh, what is that? There's a bunch of like image C or Python libraries written that were much more common and had a lot of issues. So if you know that pain, you know what I'm talking about, where a processor package called Nodejs would try to install these like C libraries, and then you'd run into like operating system specific issues, and it was a whole thing. This sort of uses that same process, but what you can do is you can like pre-build it ahead of time and then just fall back if you need to, which is I think what all those C libraries and whatnot were doing too. But with more complex publishing schemes and multiple operating systems, I think it was falling back into the great thing with C much more than it needed to or should have. Okay, so we got an Ubuntu pass, sweet. But another package that I think is kind of, I wouldn't say came out of nowhere, but it hit the scene as it were, and I feel like it's gotten much more adoption, and it has support in a way that I think is gonna make it more sustainable long term. And one of the big things is this specifically was built to support NAPI. Neon was specifically, it would support a specific version of Node.js, at least in the major versions, I believe. So every time there was a new version of Node, you would have to compile and publish an update of your package with the new version of Node compiled, which is painful. But Node.js added a API called NAPI, or I don't know if that's actually how everybody else says it, but yeah, API issues. Yep. There is, where are you? Node API. So this was a new API that was added in like Node 12 or something, I think, and Node 10. They got a table around here somewhere. Yeah, here. And it started with version 1. Okay, so I guess they started working at it all the way back in V6 and V8. I'm not sure offhand what's included in all of 1 through 3. Pretty much I would say don't ever use those these days. But for the most part, we're on version 14. You can effectively use 6 and up, I guess, is probably the best way to look at it. And that gives you, they don't have 18 on here, interesting. It's kind of funny. This is like major versions except for this specific way to like have a binding. So rather than like tying these bindings directly to the major version of Node, they like split out and have a separately versioned Node API. And that's also continued to evolve. So like this is a little bit painful, but also it means now that things are starting to stabilize out a little bit more, you can pretty much use P6 and above. And everything that I've wanted to do, I mean, I think I've used version 4, and everything that I've wanted to do has been supported. And honestly, I don't know offhand what falls into these versions. Yeah, so Node pre-chip was, and pre-build and pre-buildify were sort of the way that Neon was working. I mean, I guess it's basically all of these, right? So if we look at any of these, here, added in, there you go. So an API version, this. But there's a little bit of indirection because like we're not using these methods directly. They're kind of in that layer, the thing that gets created that we are able to call. So you have to sort of rely on the documentation to tell you which one to use. But this project came around and supported it right out of the box. Like this was specifically built to be an API. And they kind of ended up beating the Neon project to the punch. So everybody that I know of that's doing something like this, myself included, has pretty much moved over to NappyRS. And their default is to you end up getting this. It publishes the main library and then libraries for each of your specific operating systems, because you still need to, you're not limited by Node anymore. So you don't have like this matrix of versions that you have to do, but you still have to do every operating system. And depending on, I mean, we're getting ARM of pretty much all the operating systems now too. So now we have x86 or x64 and ARM. And now like the RISC-V chips are coming around. So like for this specific use case, I was like, I don't want to get into this complexity because I would theoretically want to do this, but then also need to include every one of those binaries in that action distributed folder. So I think, because we're not expecting, if we were using NappyRS, we would be expecting it to run locally, probably through Node. But you have this like build step anyways, so you can have optional dependencies that only install when you're on that operating system. And that's not ideal, but with NappyRS it helps you deal with that. And it becomes less, there's definitely less effort involved to like make this happen through NappyRS. But I didn't want to try to put all of these binaries as additional commits back into the repo so I don't have to compile. So it's very like, this situation I feel like is very GitHub Action specific, why I was interested in pursuing, you know, what does Wasm end up looking like. Okay. So we did get an error. It did change it though, so I think we might be good. I'm guessing what happened here is different line edits, which is definitely something that's annoying, but it's not. I don't think it's that big of a deal. So Windows and Linux have different what is it, CRTL, CT, gosh, git line endings. CRLF. So like depending on your settings for that, Windows is gonna handle line endings a little bit different. So like the last line in the file is going to be different, and sometimes that ends up looking like a changed one. It's actually not. So I think technically I think we're golden, because this was the before and this is the after, and you can see that they changed. So I'm guessing what changed is the line ending changed, and that's why this is not checking, which is fine. So I think we can call this a good test. The one thing that I would potentially be interested in is seeing if Rust could also write. I don't know what Wasm can handle as far as that goes. And I think they did specifically have a call out. I feel like they had a call out somewhere here that said, I don't remember where it was now. Profile target. I feel like there was a call out somewhere that said it's got limits as far as file operations go. So I think this is for GitHub Actions specifically. I think there's potentially value in using Wasm-pack to create a Wasm file instead of using bindings like the nap-yarr, because then you only need that one file, and if you keep all of your OS specific things in Node, because it's GitHub Actions is going to be run from Node. If you do all the other lifting, in Rust, and then file operations and that little wrapper are the only thing that ends up being in Node, I think you can get a pretty decent story about a cross OS GitHub action that uses Rust as within the function calls and such. My Stream Deck is still. I think I mentioned this earlier on the stream, but I have buttons via Stream Deck to do stuff in OBS. They just all died. They just went away. I don't know. I went to press the button and it was gone. So I gotta scroll and clicky. Not as fun. So I think we can call this a success. This actually went a little bit longer than I was expecting. Is what it is, I guess. I think generally I would say if you're using Node, use snap-yarr. If you're doing GitHub Actions, or if you're doing GitHub Actions, I think using Wasm-pack could be something that's useful. If you're doing something on the web and you want to use Rust, I would say Wasm-pack is a potential. It might make sense as something like a worker, where you can spin off multiple worker threads and throw heavy compute at this Wasm module as a separate thread that comes back in, delivers state or changes the DOM or whatever. I think if you want to go full Wasm though, it probably is going to make sense to use something like Leptos or another system that is built with the intention to be just take over all the Wasm. Great. I'm glad you got something out of it. Do you have any other questions? I feel like we kind of hit on every possible way that we can do Node and Rust. I mean, the only other real method I think is going to be FFI. I think they've got I thought they had an FFI in here somewhere. But I feel like that ends up coming along with the complications from the Nodejs days, and like the cmake.js. FFI. So like I think this is potentially the other way to do it, but you're creating bindings to native libraries, so you still need to be able to run that native library on your system. And I think for the most part this ends up being more of a low-level interface, and I think this is actually, like, if you're using Nodejs, you are doing the Nodejs is the thing that's taking your package and like getting it to the user. But to actually use it, I'm pretty sure you'd use FFI. But I've mostly used, I haven't actually needed any of this until nappy.rs came around, or well, nappy came around, and then yeah. So I didn't really like dig into any of it and need FFI until the nappy API was available, and then I was working with Neon, and I've converted a couple things over to nappy.rs and used nappy.rs Greenfield as well. So I haven't actually used FFI at all, but I know like Dino does use some FFI things. I've seen those floating around, specifically as far as like starting up WebView and such. But that is a whole nother topic for a whole nother stream. So success. I think we're good. I think I'll end up using this. I'm glad it worked out. Maybe we'll do an actual like full video on some of this, because there's a lot of rabbit holes here. I think it would be an interesting video to make that explains everything pretty succinctly. So, but future work. There's always things to do. Otherwise, I will see you again next week. Same time, Tuesday. I guess it would be 11 Central. Hit the subscribe button wherever it is. I can never remember where it is. Subscribe, hit the bell, and yeah, you'll see. I put all of my streams up as scheduled streams, so you can see what the top is going to be ahead of time. Otherwise, I'll see you next time. Have a good week. Bye.